William DeSalvo has 40-plus years of experience in the anatomic pathology field, 36 years as a registered histotechnologist by the American Society for Clinical Pathology, 11 years as a clinical histology laboratory consultant, and 12 years as a product marketing manager. He earned a degree in biology and chemistry from Southeast Missouri State University, received training in Six Sigma and Lean methodologies for process improvement, and is an active practitioner of continuous process improvement consultant. Bill has developed a quality management system for the histology and anatomic pathology laboratories, and for the past 15 years, he has provided educational presentations and published multiple articles on process improvement, standardization, and automation in the histology laboratory to organizations and laboratories all over the world. He is currently working as an anatomic pathology systems manager, consultant, editorial staff member on clinical laboratory products, clinical coordinator, and adjunct faculty for the Applied Sciences Histotechnology program for Phoenix College, and has previously volunteered as an executive board member and membership committee chair of the Digital Pathology Association. So it is again a great pleasure to bring you to our podium. Bill, welcome.
Well, thank you, Rick, and good day to all. I'm very happy that you've all decided to come back for a second helping of my presentation. So today we're going to talk about, it's a circular issue for histology, but it's about mitigating risk and improving patient safety. There are so many difficulties, opportunities for us to make improvement, and as we continue to move forward with, we'll summarize it all into precision medicine, it is in our best interest, and most importantly, the patient's best interest, that we move to a better, controlled process, because now the demand from patients, as I've been exposed, is that we no longer provide stains, diagnosis, differential diagnosis. We're now going to be asked, and are being asked at this point, to validate our diagnosis and our results. That's very hard for us when we're in a qualitative process where yes and no are our answers. For the purpose, this is the disclaimer, sorry about that. Now, for the purposes of today's discussion, there's so many different areas when you visualize the process from start to finish in a histology laboratory. But for what we're going to talk about is the development of a controlled production process. We are producing slides and then for stains, and we need to be predictable in what we do, verifiable, and always cost-effective. The cost-effective part is really pulling at us lately because of continued improvement in the automation of opportunities for us in the laboratory. But I may have seen two in the world so far, laboratories that are completely automated from beginning to end for the histology process. I don't see that as realistic for us in the U.S. anytime in the near future, so we are a multi-function process of manual, automated, then back to manual, or automated for 2 steps and back and forth. So all of this creates even more demand on us controlling the production process. We need to get into the practice of doing multi-point QC for our critical tasks. And when I talk about critical tasks, we're talking in the histology, pathology, laboratory, clinical. We're going to talk mostly clinical laboratory today. We're talking about accessioning. That's the receipt and labeling of all of our specimens, gross dissection, tissue processing, and there are multiple options there, staining, and today that's kind of where we're going to focus in on that staining, and then embedding before staining and then staining. So we need to create multiple quality control. I still today, either as a CAP inspector or consultant in a laboratory, somebody will run a control slide at the beginning of the day, and maybe at the end or wait till the next morning. That's just not going to continue to work for us, I don't think. So we have this big demand to continue to reduce our variance, and that demand is a compliance part. But the biggest thing is what I mentioned right at the beginning. Is we have patients, patient advocacy groups asking us, can we validate our results? Yes, we have a pathologist at the end, and the pathologist is ultimately responsible, but everything and anything the laboratory, histology laboratory, can do to reduce that variance will be of value. So it's about creating that controlled process, creating value, and being able to be very, very confident to the validation level of the results that we turn out. So here's what our responsibility is. Here's what we must do. I mean, think of it. In your laboratory today, how many of us are using a simple Levy-Jennings chart to track, control, and figure out where we are in our process? Well, it's hard to do when our answers are either yes or no. We need to get to more of a quantitation, and that's going to happen, but we have to start using these simple tools that have been used through other laboratories, GLP, research, and really start to learn what the upper and lower limits of each of our processes are. So that's controlling the process. Defects exist. When we're in a manual process, defects will exist. Now we have to find a way to identify them, correct them sooner than later, and not allow them to get to the pathologist. But we have to get into a different mindset about what our quality control is. We also need to understand in that control process that where should we put our effort to get the best results. And that's something we're going to discuss a little bit later, but you know, when you look at what part of this process am I going to operate, I think one of the most important questions that we should all be asking is what's the cost, what's the effort, and what am I going to get out of it? So we'll cut through all these other slides, and we'll end this right now by, I'll tell you, automation can't fix all of our issues, problems, and defects. It still is a reliance and reliability of us to control that process. Until we have a completely automated process from specimen goes in to stain comes out without any human touching it, we have to decide where to put our effort to get the best results. So in histology, and this is how I have kind of approached QC, that there are 3 levels of QC activity that we can attain in any sort of process. But let's talk specifically about the histology lab. The first one is level 1. That's where we have so much problems. We're behind in our production. We have conflict between our manual and automation processes, and the technologists have very little time or no time to comply. Well, I think most of us tend to be mired in that level. It's very hard to move to a higher level or a different level when you're constantly looking at how you're just going to produce today's work. But it is necessary for us to get to level 2, to where we have enough automation, and automation is necessary because we need walk-away time to put back into our laboratory process quality activities. Now, once we get to level 2 and you have a certain level of automation, and hopefully some co-location where 2 pieces of automation are directly or indirectly connected, where there is little or no human involvement, now you create at the level 2 time for the technologist to analyze the process and actually improve the process, not just produce. And then our ultimate goal is to get to that level 3 of quality control. And again, very, very few of us have the opportunity to where we have a stratification. You need a stratification in your workforce where you have bench people, you've got coordinators, technical specialists, supervisors, managers, quality managers. there needs to be a stratification, and let's face it, not all of us have that opportunity, but you're pretty much in a production by automation. That's exactly where the clinical lab is now, almost 40 years ago, and the technologist is constantly engaged in quality assurance. So that's a goal. I think those are realistic goals for us, and I think that's where we have to go in the histology laboratory, just that I find that most of us are mired and stuck in the level 1. So what must we do? We've got to create QC check measurements or assessments that do not self-eliminate the errors. So that's where I get back to having that controlled process is really our manual human responsibility. So you put in a piece of instrumentation, and today we're going to talk specifically about the staining aspect of it, that when the pathologist gets the stain slide, and stain we use as an all-encompassing from anything from an H&E all the way up through specialized techniques, but that is the term we use to discuss, is that it's very simple. Poor production process will result in poor production results. So you've got to practice a level of inspection at all those various stages in the process. So when we're talking about staining, we're talking about where are the most opportunities for us to create a defect. And that defect is extraneous tissues, or as we commonly know them as floaters. Now, there is a lot of information out there about floaters, the incidence of the opportunities to reduce and remove, but again, think of controlling your process and where you're going to put your effort to get the best results. So, we've got these patient demands, we've got pathologist demands. Slide review is their conversation with the patient, and that slide review starts with the H&E, and the H&E is never going away. They prefer a focused one-on-one conversation. When there is anything else on that tissue section or on that slide that is not anticipated, that creates them to slow down, question quality, and that is actually the creation of the defective error. It's a cross-contamination. And it typically will create group discussion, whether that group discussion is with you in the laboratory or with another peer before they come to a decision of what they're going to do. And then their compliance comes from, our compliance comes from collaboration. It must be a partnership between pathologist, technologist, the process that we've created, and the type of automation that we've placed into the process. So again, we go back to how do we validate our tissue diagnosis and we have good verifiable results. So again, let's focus on the stain slide as it goes to the pathologist. There have been multiple, and at the end of this presentation, I give you a list of all the things that I've been able to find and look at, but I tend to be very, because I am a CAP inspector and participate in clinical lab, I tend to look to CAP for direction a lot of times. So their last publication was 2010 with a Q-probes investigation, I'll call it, Q-probes investigation. So that was retrospective, so they had multiple laboratories go back into all their previous stain slides and signed out, and prospective. And they came up with floaters represent a diagnostic error of about 0.01 to 1.2 of the slides. Now, that's not acceptable because our goal is always 0, but this is where it starts to get fuzzy, it starts to get complicated, whether pathologists all agree that there is a problem, whether laboratories agree, and whether even vendors agree there is a particular problem. But as we move farther and further into the precision medicine process, and let's just, for the basis of this discussion, that is, let's move right to the companion diagnostics. Well, floaters become even 0.01% can become more of an issue. So we do have to look at those critical tasks that can contribute to the floaters. And again, that Q probes, their designation was gross dissection was a major area of concern, and so was microtomy because of tissue flotation water bath. But all 5 of those, gross dissection, tissue processing, embedding, microtomy, and then the staining, all can contribute to, there could be an extraneous tissue piece or floater on a stained and cover slip slide. And I guess there's actually 6. It can be us. If we're not wearing gloves all the way through the process, there can be cells sloughing off from our touching of slides and that. All of that becomes more and more addition to the discussion as we move to more precise diagnosis. So very simply, in-process QC is critical. So you have to find a way to apply your efforts into at least those 5 areas of our process and make sure that we have a good check, identify, correct process. And all of that, you know, we can muddy this even further. That's Six Sigma, that's lean, but it's also common sense that you cannot let anything go, whether it's a manual step or process or an automated step or process, without some sort of continual QC, QA process to that. So automation alone can't eliminate. So if you're finding that you have floaters that are not embedded in the tissue, where could they happen? If they're embedded in the tissue, where could they happen? So that's the first step in this. But again, there are opportunities for defects and errors to happen. Automation can't eliminate it all by itself, and we have to decide where we're going to put our dollars and our effort to get the best results. So what are opportunities? Gross dissection, there are multiple. When you think about it, someone who, I'm hoping that all of you have had some experience of either participating in the gross room or being oversight or review of that, but multiple specimens moving past an individual. So there are all kinds of opportunity for non-compliance of your quality process. Tissue processing, putting multiple tissues over into one reaction chamber creates opportunities for defects. Embedding, if we don't have compliance on the cleanliness and how we handle one piece at a time, opportunity. And then microtomy, from the cleanliness of the area, the use of any kind of spray refrigerants, the cleaning of the stage, the cleaning of the knife, the cleaning of the water bath, where we placed our tissues before and after, all those create opportunity for error. And then staining. If you have an open system, more commonly referred to as a dip and dunk, or a closed system, what's on that slide or what's in that solution can create opportunity for error. So I'm hoping you see that one point or end point often with the pathologist, we wait till the pathologist looks at the slide and says, this is okay, or no, it's not, really cannot be continued in what we do if we're going to be able to have confidence and validate what we do. But as you can see, there are multiple areas that create the same result to the pathologist. And when the pathologist receives that stained slide, I'm of the opinion, and this has been with conversation with pathologists, they have two determinations they make. If it is on top or somewhere else on the slide, and it is, we'll use the term floater, they feel that it happened someplace other than the grossing dissection bench. If it's embedded into the tissue and it's a clump of cells, or at least more than one cell, clump of cells, and it's more embedded in with the tissue specimen. This becomes more of a problem when we get to biopsies. They will then think it's gross dissection or did something happen at collection. So very complicated, very time-consuming to go retro back and work back through your process. So setting up a good QC/QA can give you a lot of time back into the laboratory to continue to work on your production and your quality. So, gross dissection, these are simple, the gross dissection board. There has to be a cleaning each and every time you use specimens, forceps. And then what you're going to do about your fragmented tissue cassette management. You know, is that going to go into a mesh cassette? Is that going to go into some sort of processing paper bag? Something that helps to secure that fragmented tissue. Now, when we have a large piece, even a large dissection and resection piece, and it goes into a cassette, there is an opportunity of sloughing off of cells through the fixation and processing steps. In tissue processing, it's all about fixation. If you have poorly fixed tissues, you will tend to have more sloughing off of cells. If you're rushing through your fixation, you may not have a good rinsing of those cassettes to make sure that you removed as much as possible anything that could be free floating. Then you've also got your specimen prep and your solution management. And solution management is very, very important. I still go into laboratories and people will say, well, you know, we change the processor once a week whether it needs it or not. If that's once a day, that's 5 times that you've exchanged tissues. If you look at the filters in the instruments, cells, multiple cells, can easily get into your tissues. So you have to set up into your solution. I mean, so we as individuals, we have a piece of equipment, we have a manual process. We have to set up what is the check and recheck of that process. Embedding. Very varied opportunities here. Mostly forceps and embedding surface. If you do not have a compliance of cleaning the forceps, cleaning the embedding surface in between cassettes, you take the risk of introducing something else into the embedding mold. And then the third one is always consider the paraffin in the holding area. If you do what they call dry embedding, where there is no additional paraffin, that has its own issues, or if you do wet embedding, where you have paraffin. Anything that's sitting into the paraffin has a time factor on it, but also because it is molten in a liquid state, there is an opportunity for our cells, chunks, pieces, bits, to slough off of the tissue in the cassette. So again, a good check, good compliance. Microtomy, anytime you have under-processed tissue, you could get pieces of tissue all over the place. If you have properly fixed, properly processed, you should only have, you shouldn't have a fragmenting of your paraffin ribbons and sections. You should have just those sections, and you should be able to keep that whole cutting stage area clean. The more you have fragmentation, you've got poor underprocessed tissue, the harder it is to keep that clean. And then the water bath. What is your method? What is your process? Is it between every ribbon, and how do you clean that? How do you identify that? Too often, I still go in and see water baths while people are talking to me and working. There's pieces of tissue floating in there. If you use any sort of aerosol spray, not only do you take the opportunity to introduce that to the water bath, your cutting stage area, but you now, because it's aerosol and you've made it airborne, you could introduce floaters and problems, defects into the next cutting station. That somebody who's working in a compliant way thinking, well, you know, I don't use aerosol, I don't worry about it, somebody sprays, and now you have tissue fragments that have been airborne. And then this is one I'm always aware of, is slide location and slide storage. Is there more than one slide out in the work area? Because as you're working, an introduction. So all of this can create floaters. So in staining, once we get to the stainer, and so we'll talk about the two options we have. We have open container, whether that's a manual or an automated. So we have a certain volume of solution, and then we have the closed system where it puts discrete volume for each step of the process to a individual slide. But in staining, the most important thing is making sure that you have the proper slide drying. If the instrument has a drying method, an oven on it, use it. It's been validated, it's been cleared through FDA, it works. So drying your slides properly, because what we're trying to do is not melt off the paraffin, we're trying to get the water, drain the water from the slide and out between the paraffin section and that borosilicate piece of glass. And then the glass is even more important because we have hydrophilic and hydrophobic glass now, where they keep changing the chemistry on the glass to whether something's going to stick or not stick. So you have all these different opportunities, but all of those create an opportunity for defect. And it doesn't mean whether the manual process, the open, automated, or the closed is any better or worse for it. So this is back where you look at how do we put our effort and our dollars into what we do. Again, before you spend anything for automation or change of process, make sure you have a way to check and confirm compliance to the best. And then solution management, whether it's manual or an automated open system, there has to be multi-QC check. Frequency varies. So depending on your volume of slides, if you're in a large laboratory and you're running thousands of slides a day, maybe you're checking every couple of 100 slides. And I know everybody's going to pause. Well, you mean I got to stop the process, run a QC slide, and before I do anything else? Well, that's the standard method. You can also do multi-point check of your process by putting QC slides in with a staining rack. But that still means that all your slides need to be reviewed before you put those out, at least the QC slides. And if you have nothing on that QC slide, then you're able to put out that rack. But depending on the time constraints on your process, how you can do that multi-point QC check. And then that in-process, that's what we were talking about. The in-process is putting a blank slide in a run. Find out how. You know, how many of you out there know that if I put 600 milliliters into a staining vesicle, how many actual slides do I run before I need to change, before I need to replace, rotate? How many slides can you in your process get out of 600 milliliters? The vendors all have a number to throw out there, but what works for you? Have you done a validation and worked with the pathologist to say from slide 1 to slide X, everything looks the same? After that, we either need a addition, change, rotation, clean the container, all of that. Those are the things that too often we just assume I bought an automated instrument, all this works without any further input or effort on our part. So, again, our number one identifier of all defects, and that happens even in all the laboratories I've worked at, is that yes, we run QC, yes, we need to make sure the process is performing, but the pathologist is still the one that must identify what's under that cover slip. Is it a defect or is it not, and they're going to sign out the case. Then you have to be able to do some root cause analysis. You know, what is the scope of the issue? Again, somebody comes in and says, you need a certain instrument, a certain change in your process because there is a problem with X. Today we're talking about floaters and extraneous tissue. There needs to be a confirmation for the way you run your process because everybody's step-by-step process is different. You need to identify what's the scope of the issue. And that takes involvement, partnership, and communication with the pathologist to decide what is the scope and what can be done about it. And often it may not be that you're going to spend X amount of dollars on a new instrument, it means that you may have to step back and go 1, 2, or 3, or 4 steps into the process and create a new quality assured step-by-step process. It does require, though, immediate management. This is not something that you can wait for the pathologist to come to you and say, hey, by the way, I think we have a floater issue on our slides. In my experience, that can be anywhere from multiple days to multiple weeks. So it takes immediate management by people in the laboratory. There has to be, and if we go back and you think about that first slide with the Levy Jennings, there has to be identification and documentation of all defects and errors. Whether they result in a rejection of a slide by the pathologist, but you need to know and keep daily aware of what the scope and what can be done to do that. And again, expectation of the manual to automated process is that one of the things that I always had angst about is that when we introduced the automated immunohistochemistry instruments, there's one of the most important stains that we do, and also the biggest revenue generator for all of us in the clinical laboratory, is that we put this automated instrument at the end of a very manual process. The best instrument out there can have varying performance from lab to lab depending on how well and how controlled your process is prior to placing the slide on that instrument. It is the same situation when we talk about any automated instrument, but today we're talking about staining in particular. Before you place that slide onto that instrument to perform those multi-steps and to create your stain, whether it's an H&E, a special stain, a lot of automation there, or IHC, or IF, or even further as we go out to all the new techniques that may or may not be used, it is really the responsibility of us to control that process. So what is your expectation for what you're going to get? And then what the next decision needs to be is, am I going to spend that effort and those dollars there, or can I spend the same effort, possibly the less amount of effort and less dollars to give me better performance overall in the process? Those are the difficult questions that come to us each and every day. My worry is, as a consultant, is it's too easy for us to accept that there's an automated solution, and there very well may be one. But depending on what the manual steps are before and after, and how well those are controlled, you can almost cancel out the benefits, and you can get to canceling out the benefits of that automated step. So it doesn't matter whether you stay all manual or automated at this point, it still is incumbent upon us in the histology lab to move to and pass that level 1 QC and try to get to 2 and at least 1 or more people in the laboratory who are functioning at that level 3 control so that we can get to validating our results. Next, I'm just going to show you a couple of just pictures of what I'm talking about. So on the top left, it's a grossing board. Each and every time you go into the gross room, is that as clean as the grossing area is? When a PA or a grossing assistant or a pathologist is working, is that as clean? That's exactly how clean it should be. You look at the middle, that's how clean the grossing area. And I will tell you that that's a very rare sight in most of the laboratories I work in and in most of the laboratories I visit. But that, as we move to precision medicine, that's exactly the expectation that the patient has, is that each and every time we work with a specimen, we're working at that level of cleanliness and compliance to our quality process. Over on the right, these are some of the things I pulled off of different vendor sites, I'll call it. They have an X through them, and the X is the forceps are serrated. So my suggestion to everybody is in the gross room, in embedding, and at microtomy, no serration of forceps. Look at the opportunity for tissue to be captured into those serrated areas. That can easily be carried over to another piece of tissue and into the next case if there is not 100% compliance of cleaning and maintaining a clean work area each and every time you work with a specimen. Already I can hear people say, we could never get our work done if we did this. Well, yeah, we could. Think about the time that we're wasting by backing up and investigating and everything else. Yes, once you set up a good controlled process, you will be able to maintain your productivity. It's like anything else, it's going to take a change, but you will be able to maintain and possibly increase your productivity. Then it also makes it easier when you have a controlled process to identify, select, and implement the next piece of automation in your laboratory. Cassettes. I have a lot of issues with cassettes. On the left comes from our sponsor today. Why do we decide to force all of the cassettes we can, and if we're leaving that to the person who loads the cassettes, whatever the recommended by the vendor is, someone will try to put one more cassette per rack. You've got all these different tissues, all these different basically combinations of complex tissues with an opportunity for something to slough off and move forward. And the biggest thing I have with this is that when you use an instrument to capacity, and I can hear all the vendors cringing right now, use the instrument to capacity, you're just not going to get the same performance. If you took 2 or 3 cassettes out of each one of those rows, you have a much better flow of solutions, you have a better exchange of those solutions, and then off of that, if you look at those different cassettes, we go to mesh, you go to different size holes, there are tissue processing papers. I didn't put up my biggest angst, which are sponges, because that is just such a problem with carryover in my mind, but there's so many different options, and it really should be one specimen container, whether it's fragmented small biopsies or whether it's a resection, one piece of tissue, one set of fragments per cassette. We've got to maintain, if you're not maintaining that, or you're trying to put too much into a cassette because you don't want to do a second cassette, just more opportunities for error. So controlling the process also means you have to control everything about the process, even what's going into the cassettes. And then when you talk about the tissue processor, it's solution management. Is really in today's laboratory, is it rotating some solutions, changing out once a week? Again, there needs to be a good validation of if you're running cassette racks, such as what is pictured, is once a week the right number? Who knows? You have to validate. So you have to have solution management. There are many instruments out there, and this is where automation comes back in, that have solution management options for you, that help you maintain a certain specific gravity or dilution factor in your solutions that are going to be used in processing. What they can't manage at this point is whether or not there's any other tissue floating in those solutions. That is still our responsibility. So your frequency, reducing load capacity, and then making sure that your samples are secured. How often do you come into an issue where a cassette may be open and somebody says, what are we going to do about that? Or you pull out the rack and there are tissue fragments in the bottom. Throw away those tissue fragments. Unless you do DNA sampling and you know who those patients were, there's no way of identifying who they belong to. So that's an indicator that you may have to do something different in your cassette management if you're seeing fragments of tissue left in the chamber. Well, cassette management or fixation, grossing technique. Again, multiple opportunities here to make sure this changes. Embedding. Again, these are some things right off of the vendor sites and some things on there. Multiple specimens sitting open around, making sure that you've got non-serrated forceps, things like that. This is one of those areas, along with microtomy, that working with one piece, and that one piece is a cassette, one piece at a time, and making sure there's a compliant cleaning in between each and every one. Microtomy, there's so many. There's, again, just some pictures out there on the bottom left. If you got good process, good fixed tissue, that should be what you're looking at while you're trimming and everything else. Here we have, in the middle, we have somebody trim, just leaving all of that debris. All it takes is somebody to cough or whatever, you've got tissue floaters. The work area needs to be clean. In the middle, on the upper, there's tissue fragments laying all over the counter. Lay a slide down, it flips over, you now have tissue fragments. And then my favorite is, this was right off of somebody's YouTube video of how to do microtomy and pick up tissues on a tissue flotation bath. And I didn't even circle the fragment that is sitting right next to the top ribbon, but there's tissue fragments all over the water bath. It is incumbent upon us as technicians and technologists to work in the highest craft that we can. That is not a good craft controlled process there. Those are where I see the opportunities for floaters and extraneous tissues occur way before I get to a stainer. Now, if I control all of those, I have a much easier time controlling the staining, whether manual, open automated, or closed automated process, and being able to validate and have confidence that that stain cover slipped result that comes after. So again, solution management, in-process QC checks, frequent solution change. And make sure that you have completely drained and dry slides before you move into your staining process. All of those, you concentrate on that, you have a better opportunity to be successful with your automation. Immunohistochemistry, there are so many different things, but fixation techniques, it creates a cross-link with proteins. We've got all these antigen retrievals. You have incompletely processed tissue samples that we're trying to do immunohistochemistry. The whole idea of this slide is immunohistochemistry is a very complex and it is the most precise process, because that's also involved in our predictive markers out there, and we need to pay more attention before we ever get to cutting a block for immunohistochemistry. So again, what are the improvement opportunities? Those are the 5, in my mind, that we have to do a good level and get past level 1 QC, but often I find that there's not even a good level 1 QC process. That's multi-point check of identifying, correcting as soon as possible. And again, back to the other premise that I have is you should hopefully be able to get to 3 different levels of QC in your laboratory. I understand the difficulty with the constraints and the pressure on producing and why it keeps us in the level 1, but you have to find every lab, you have to find a way to get the first person to start doing level 2 and the first person to start doing level 3. Or you're continually working and reworking your results, and you may ultimately spend very valuable and not so frequently available dollars in the wrong place if you can't get to those other levels of QC. So, control the process, whether it's a manual, automated, open, closed, it requires rigorous QC by us. That's time-consuming, but it does require. You've got to be able to create effective and multi-point QC checks. Better QC gives you cost-effective automation. Automation can't fix your errors and defects alone. You have to be in a controlled process and participating and complying before you can really gain the benefits of whatever that automation is you're going to purchase. As I mentioned, here's some of the references. I encourage all of you to look at this and see what's out there. It's very hard to get consensus across all the laboratories and pathologists that there's a big problem. There is an issue. It's a continuing issue. I think it's important that we start addressing that now before we move to any further precision in our staining techniques. Rick, I'll give it back to you. I hope we covered the things you wanted me to cover.
We did, as always, Bill. Fantastic presentation. Thank you so much. And we do have some questions which we can go right to. First, what should be the mean time in days to change a battery of H&E stain in a frozen section room performing around 10 procedures a day to ensure a good stain on slides?
Oh, that's pretty thoughtful. Because we have no standards in histology, that would be a validation protocol that you should do. I would suggest a filtering. So in my world, your number of frozen sections is a very low volume laboratory compared to some of mine that are doing 60 plus cases a day. But there is no set standard, so it's hard to tell, but that requires and speaks to me that a validation process. There should be a filtering of solutions on a regular basis. Depending on the type of tissues that you're working with, I would suggest that if you're doing all diagnostic biopsies or all skins, that your frequency of filtering solutions would probably be a little higher if you're doing a resection piece of tumors. But all of that, depending on how fast you're freezing, how well you're able to cut, you have a very high opportunity that you may have a fragmentation of tissue that could come off in your solution. So multiple time, I would say some sort of multiple time through the day, you would want to filter and or change whichever is most cost effective. And then doing it by validation would tell you exactly how often you might have fragmented tissue that's sloughing off of your frozen section slide.
Excellent. Thank you very much. And there is another question that I can take actually here, but I'm going to read it because I really do like it. It says, fantastic talk. Will it be available so that I can discuss it with my histo team and also with management? And yes, of course, it will be. We are recording today's event, and it will be listed on the Pathology Leaders website, webinars website, where you can access the recording in a few days, and we'll be providing you with the link to the recording, to the page that I just discussed, in a few minutes as we draw the webinar to a close. But let's move to our next question. First, what are the three, I'd like to remind everyone, by the way, to use the chat box and the Q&A boxes to send in any questions that you have, because we do have a few minutes left here, and if you have any questions, this is the time to get them answered. What are the three main task areas of concern for creating floaters?
Okay, so I have my own personal preference, but I'll go back to the CAP Q probes. I would say the number one is your microtomy area, just because anything that has not happened correctly in your process, fixation, processing, and everything, all lands to the person who's creating the slides at microtomy once they put that block into the chuck. That has to be one piece, and cleanliness has to be complied with. The next biggest area is the gross room. Any drift in compliance of clean instruments and a clean grossing area, whether you're using pads or rinsing in between, using a hard surface, That is the second one for me. Third would be embedding. Again, if you follow good operating procedures, standard operating procedures, and comply, you should be able to reduce that way below the point, down to that 0.01. Remember that in a manual process, we can never remove all of the defects, maybe on a day for a time period. But again, microtomy, then grossing, and then embedding. But they demand a one-piece flow and then a cleanliness compliance in between those units or pieces. So grossing a specimen, cassette microtomy, a block.
Excellent, thank you. Now here's another thoughtful question. During staining, what is your QC recommendation for validating a product, for example, a detection kit, which constitutes various subcomponents obtained from multiple vendors?
Well, I think, first of all, I would go to your CAP guidelines. They give you a lot of good information about how you're going to do lot-to-lot validation. Second, pathologist always needs to be involved, and you have to then first design your plan of what type of staining you're going to do when you develop your protocol. That's not unusual for a laboratory to have an antibody, a detection kit, and everything from multiple vendors. We're not to the point yet. There are opportunities, but I don't think most labs are to the point where they're buying everything from one vendor. So it is just, and there's a lot of information out there between CAP and other resources of how you develop that validation protocol. Whether you decide, and statistics come into here. One slide is not a validation. 2 or 3 is probably not a validation. So you have to have that conversation of where you're going to get to a statistical number that says, if I look at all of these and 1's out and 5 are in, is that a correct stain or not? And in my world, statistics start about 6 samples. That's probably the very lowest end. But that is a discussion between guidelines, regulations, and pathologists, medical director or pathologist over your area, deciding what is acceptable for you to do that. Anytime you change any one of those components, a new validation has to happen.
Wonderful, thank you. And interesting question. Can you explain the 3 levels of QC you referenced in your presentation?
Okay, so I can't even remember where I came to that realization, but level 1 is we're just trying to maintain our high production, and you have put in place, check, identify, and correct at least at all of your critical steps. That takes some time, effort, and participation. Level 2 is now you're moving with to more of a quality assurance, because you're now with the level 1, I will also say is probably your biggest data collection area. So you're collecting the data. Level 2 is now you're working with the capabilities and capacity of automation and or with the data, working towards quality assurance steps to continue to reduce your defects and errors. Level 3, you're working with all of the what-ifs. Now that I have all of this, if I do this, what will change? So level 3 is almost all quality assurance. You still have a certain number of people doing level 1, a smaller group doing 2, and a smaller group of 3. The difficulty, maybe I didn't explain it well, is that too many times I walk into a lab, and even on certain days in our lab, everyone is involved in level 1, and you're never going to get past just identifying defects without being able to get to those other 2 levels and start working on ways to prevent the opportunity before it even happens.
Excellent, thank you. And we have time for one more question. Let me see if I can expand my real estate here so I can see it. Do you recommend emptying the paraffin tray on the microtome between cutting each block?
Ooh, that's a tough question. There are multiple opportunities there. Cleanliness is most important. Now, I've seen a couple of things. People remove and dump their tray. I have also been, it was in a different country, when they have their collection area for their trimmings, before they go to cut the block, so they'll clean their stage, their microtome knife stage area, and then they will place a paper towel over their trimmings before they cut their next ribbon. A clean paper towel. Could be, depending on how big that is, but it definitely cannot, it has to be managed, the number of trimmings, because, especially if you're using any kind of aerosols, because if you have anywhere within about a foot or so of that blade cutting stage, you can create lift of all kinds of fragments. So it is either a frequent dumping or something such as I saw in Europe, where they place a paper towel over all of their trimmings before they start cutting their next specimen ribbon.
Excellent. Thank you again, Bill, for the responses as well as another great presentation. We do appreciate that, and we have reached our scheduled stop time. So let me just quickly, briefly remind everyone that if you have anything that you'd like to contribute, whether it's an article or a presentation for a webinar, then please contact Eric Heilman at Leica Biosystems at this email address, and Susanna will put that into the chat box so that you can copy and paste that. And if you'd like to access the recording from today's webinar, you can do that in a few days at this LeicaBiosystems.com/pathology leaders. Susanna has put that also into the chat box. Thank you, Suze. For those of you who would like to receive PACE credit or Florida Laboratory credit or a certificate of attendance for attending today, here's how that's going to work. When you leave the session, you'll close the WebEx window and you'll see the evaluation open in your browser, so do not close your browser, just the event window when you're ready to leave. Fill that out, send that right in. For those of you who are joining as part of a group, if you're the person who's logged in today, forward that email to everyone in your group so that they can access their evaluations as well, because the link is in that email. And the same thing applies to anyone who joined on a mobile device, since the evaluation will not open in a browser when you close the app on a mobile device, but you will be receiving an email from messenger@webex.com. Again, that's messenger@webex.com. Keep an eye open for that. You'll be receiving your evaluation or your certificate of attendance in a link in an email within a few days, as long as you send in your evaluation within 24 hours. Otherwise, it can take up to 2 weeks to receive your certificate of attendance. If you have any questions that come up over the next few days on this topic, send them here also to Eric Heilman. You have that email address already in the chat box. So for those of you who would like to join us again, please visit Pathology Leaders, and you can always register for upcoming webinars as they are posted. But a big thanks to you, Bill, for a wonderful presentation today. Thank you so much.
Thank you. Appreciate it very much.
You bet. And a big thanks to all of our friends at Leica Biosystems for sponsoring today's event through Pathology Leaders. And, of course, the biggest thanks go to all of you for joining us, and hope that you will join us again very soon. Check out the chat box before you go in case you want to copy and paste any of the links that we've provided there for you. So thanks again for joining, and we'll see you at the next webinar. Bye-bye, everyone. Have a wonderful rest of your day. And, Bill, thanks again so much for a terrific presentation.